All right. Wow. First community stand-up of the year. Welcome. Howdy, Mackinnon. Howdy, Daniel.
Hello, John.
This is exciting. So today we are talking about, I have a banner prepared, new and experimental features. Starting the year right. It's amazing. All right. Well, starting with introductions, I'm John Galloway. I'm a PM on the .NET community team. And we have with us Mackinnon, who was introduced in the last show. And Mackinnon is now running the Blazor stand-ups, which is super cool. And then everyone. Dan, I don't know, you do some sort of Blazor stuff?
I don't know what I do. What would I do? Like, I ask myself that every day. I'm the product manager for Blazor on the ASP.NET team.
Awesome. All right. Well, I will talk a lot less. I'll turn it over to Mackinnon. I know we've got community links here.
Yes, I have the community links pulled up right now. So, all right, here we go. Yeah, so first off, we have chartjs.blazor, which is a pretty neat Blazor library for rendering. It's like wrapper over chart.js essentially. So they have this demo website here. And with just pure C#, you can create these really cool looking charts in Blazor, and they're interactive and they have cool labels, and it's awesome and it looks pretty easy to use. I would recommend checking that out. So that is chartjs.blazor. Next up, we have I Did It, which is a completely amazing to-do app written in Blazor. It's probably, I don't think I've seen a to-do app with this many features before. So I'll go ahead and open it up and just give a quick overview. But it allows you to like assign priorities to to-dos, like due dates. Like you can search for to-dos. You can even import and export to-dos like from like in different formats, and it's really cool, and it's all written completely in Blazor. So if you need a completely amazing to-do app, certainly check that one out.
I write all my to-dos in YAML. That's my preferred to-do format. So that's great to see that it supports uploading my YAML to-do list.
I think we need to make sure David Fowler, I know he was hacking on a to-do app over the holidays, so we got to make sure he supports all these features.
Yeah.
For sure. All right, and next we have a tweet that I thought was pretty interesting by Christopher, and this is an interesting way to measure the render time of a Blazor component. So if you need to do some performance testing in one of your libraries or one of your apps, you can use the snippet to measure how long a component is taking to render. And yeah, so if you need to do that, take a look at this example and yeah, use that. And hopefully you can figure out some nice optimizations for your Blazor code.
Can you click on the image so we can see it?
Oh yeah, is it small? Sorry about that. Yep. So yeah, just overriding should render, starting a stopwatch, and then an on after render is stopping the stopwatch. And
I think we have some items on our backlog also to try and create some framework assistance and help for this scenario. Like I know this is an area of performance investigation that a lot of people end up having to do, is looking at, what are my components doing? Am I being intelligent in terms of how I render, being optimal? And a lot of people end up hand rolling these performance measurements for their render times. I think on the Blazor team, we probably have some work to think about, like how can we make this a first-class feature of the framework, and maybe even think about like tooling experiences for analyzing your rendering time. I think it's in the .NET 8 planning milestone, but I don't know if it's. I mean, we're still finalizing the full roadmap for .NET 8, but it's certainly something that we've talked about.
Yeah, definitely. Yeah, I'm not sure what the current priority is assigned to that, but I agree that would be super amazing to have in, like as a built-in feature.
If you think that should happen, go track down the GitHub issue and give it a thumbs up. That's one of the signals we use from the community about what things you all think are important.
Yeah, and in the meantime, this snippet is perfectly valid if people need that functionality right now.
Yep, that's a good way to do it today.
Yep. So, all right, next on the list, we have Fast Blazor, which might have been on this list before, but I'm putting it here again because version 2.0 of this library was just released. And if you're not familiar with Fast, or Fast Blazor, that is, it's a wrapper around the Fast library, which provides like fluent UI components. So if you need like really pretty, nice looking components in your Blazor app, check out Fast Blazor. Version 2.0 was just released. And there's like a bunch of miscellaneous improvements all around, but the biggest thing I think is integration with the new experimental QuickGrid package. So their data grid component now uses QuickGrid, so it has a little bit of added functionality, plus probably some improved performance. So if you're using Fast Blazor, take a look at upgrading to version 2.0, and yeah, check that out.
That's great. Is there like a release announcement for that? Like did they put up a blog post or something, or is it just if you want to find out what's all that's new, do you just go to the repo and look at the releases?
I believe there was a like Medium blog post about it. I don't have a link to it, but I don't have it on hand, but I think there was something.
All right.
Yes.
Okay.
John's Google.
I'm looking around. I see one, I think.
Okay.
Yeah, I think I got it. What's new in the? Yeah, here I got it. From Vincent, who is actually in the chat.
Yes.
Yeah, if we could get the link to that, I think that would be great.
There you go, Vincent. Yeah, I just tweeted, or I just commented it out. There you go.
Yeah, nice work on that. It's not just that they look nice, but they also follow design guidelines and principles that integrate well with like a bunch of Microsoft products. Like if you want to do Teams apps, if you want to, do things that look kind of like Windows 11, those Fluent UI based web components that are underneath the Fluent UI Blazor components adhere to all those design guidelines.
Yeah, absolutely. Yeah. So, and then finally we have this last link, which is a YouTube video, how to learn Blazor in 2023. This is a video by Tim Corey. And if you're new to Blazor and you want like a nice roadmap for getting started, or you just want to see kind of where Blazor is at the start of the year, check out this video. I think it should be pretty useful for those who are just getting started.
Nice. So, thank you, Tim.
Yeah.
For putting that together.
Yeah. And that's it for the community link. So I think we're ready to move on to the main topic. Yeah. So today the topic is like exploring new and experimental features in Blazor. So what we're going to be doing is looking at some new like .NET 7 features in Blazor, and as well as some of the experimental features that were released, like QuickGrid and multi-threading and SIMD support. And we're going to be building a audio browser app. Now, if that sounds familiar, it's because a similar demo has been given before by Steve Sanderson, and actually, and that was given at .NET Conf. And there's he actually has a repo with the code if you want to kind of follow along with what I'm doing. And this has most of the code. It doesn't have all of the like multi-threading stuff that we'll be getting into. But if you would like to follow along like with the full example, feel free to check that out. But that's what I'll be using today. This is meant to be similar to that demo, but more interactive. There's going to be more conversation, and we might dive into some topics a little bit deeper rather than have it just be a streamlined, like I'm just talking for 25 minutes and that's it. So that's kind of a general picture of what's going to be happening today. And with that, I guess we can jump right into it.
Yeah, so Steve originally showed this in that .NET Conf, let's build an audio app demo sequence, right? We could probably get a link to that for people if they want to watch that. Watch the original Sanderson version. We're going to get the elevated Mackinnon version in this stuff. I mean, it's a lot of the bits are also from Steve as well, that he's been messing around with things, and we're going to give an early preview. Steve's given us permission to show some of the things that he's been prototyping, which should be fun. But we'll look at some .NET 7 features, things that are still fairly new, that are highlighted in this app, and then show some of the new things that we're working towards with .NET 8.
Yeah, exactly. So let's get started. So in this project, in this solution, I have two projects. I have this audio browser project, which is just it's an empty Blazor WebAssembly app. So there's nothing really in it yet. Like index.razor just has hello world. And then we also have this Razor class library media files API. And what this does is it's a wrapper around some newish JavaScript APIs for reading from like the host machine's file system. So let's open. So like this is, like the JavaScript file system API is what this Razor class library is wrapping. In the real world, like outside of a demo scenario, you would probably, rather than writing all the JavaScript yourself, you could probably pull in like a third-party library. I think we even showed one in the last community stand-up, like a Blazor library for like accessing the file system. But for this demo specifically, we're going to be showing, if you need to do something like this yourself, how easy it actually is to set up. So yeah, let's take a look. So for this application, we'll need some basic functionality like being able to open a folder to browse files, being able to play back audio files, load audio files, things like that. So this media files class is just a wrapper around all that functionality. I won't dive into the JavaScript implementation because it's not super important, but you can see we just have a list of methods here that we're going to be using throughout the application to provide some of the core functionality. And you might have also noticed that this media files class extends this JS module class. And you might be wondering, what is this thing? Is it a framework feature or what? And it's actually not. It's just a utility class within this project. But it's something that we're considering bringing into .NET 8 in some shape or form. We haven't finalized it yet. But the idea behind this is that it provides a nice abstraction over loading and interacting with JavaScript modules. So in the constructor, it just takes a URL. It handles importing the module automatically by just calling invoke async on the JavaScript runtime, returning a JS object reference. And then it has methods for invoking the module, like invoking methods on the module. And it knows to wait for the module to be fully loaded before invoking methods. And then it also knows how to dispose of the module when you're done. It just handles a lot of that kind of lifecycle complexity that would normally be implemented maybe in a Blazor component. So, but this way you can just register the module as a service in DI, and you don't have to worry about, shoving all that logic into some sort of like Blazor component.
We have a GitHub issue actually that was opened by a member of the community, and where they had something similar to what Steve did in this application, proposing that we actually make this just a feature of the framework. If that's something that you find interesting, you can go check it out. I think it's issue 45120. Maybe we can get a link to that, John, as well. Give it a thumbs up if you like this functionality, or if you have thoughts, opinions on how this abstraction should look. Yeah,
absolutely. And definitely feel free to take this example from Steve's repo and use it in your own projects, modify it how you want, and then share what you think should be there in the GitHub issue. So yeah, that's what this library, this media files API is doing, just providing some basic audio, like file manipulation, things like that. Well, not manipulation, but accessing the file system.
Yeah.
All right, so with that, let's jump into the actual application. So here I have this index.razor page, and there's not much in here yet. It just injects that media files class that we defined in this other project, and we're going to use it in here. So let's go ahead and I've pre-written or / copied some code here. So let's just pull that in. And this is just a really basic UI that utilizes that library that was just showing. So here we just have a menu, which is going to display at the top of the app with a button. And when you click it, it's going to call open dir, which is going to prompt the user for a directory picker to select a directory with the audio files they want to display. And then we're going to read all the files from that directory and then store it in this files field. And we just have a loop that loops over all the files and displays their name and file size. So I will go ahead and get that running.
For the people in the chat that are like, oh wait, have I seen this before? It feels like I've seen this before. Yes. This is the beginnings of what Steve Sanderson showed at .NET Conf. It's the same audio editor application that we shared a GitHub linked above to the source code for the demo that Steve did. We'll go through it real quick just to show the .NET 7 features in case people didn't see that or missed that .NET Conf session. But then we have some additional goodies at the end that show integrating some of the work that we're doing in .NET 8.
Exactly. Yeah, thanks, Dan. So if I go ahead and click this open button, we can see that we have a file picker. So I'll go ahead and select a directory with a lot of audio files. And we'll get a prompt that says, oh, do you want to see these files? And yes, we do. We want to grant that permission. And here, the files that I'm using here are just some sample like human speech files that Mozilla has in their like corpus of human speech for training like a voice recognition AIs, but that's not really important. But we have like, I don't know, a few hundred files in here. It doesn't look the greatest because we're just, it's just like a list of text basically. It'd be really cool if we had some sort of way to display this in like a table or a grid of some kind.
We had a grid, Mackinnon.
Yeah,
there was a grid component somewhere.
If only we had that, right? Well, and it would be really cool if we went that far, if we could do like search functionality and maybe like sorting by different like columns and things like that. But that sounds like a lot of work. So should we really do that? Well, actually, it's not that much work because we have a new experimental grid component released as a like separate experimental package in .NET 7. So let's take a look at how we might use that grid. And it's called QuickGrid, which some of you might have heard of. So we will go ahead and take a look at that. So currently we just have this loop that's doing all the rendering. We're going to delete this and pull in the QuickGrid version of it. So, and there's a lot here. So I'll walk through it one thing at a time and kind of explain some of the features that it has and how just this, 15-ish lines of code can handle all that functionality. So
can I just interject and say how happy it made me to see you resolve the using statement for that component just by using the code action gesture. Like, so I think it took for years, we didn't have that feature in Razor. When it finally landed, like, I don't know, maybe a year or two ago, we finally got that and using directives in Razor files. It was so nice. Just hit a button. It's great.
It's a lifesaver. Every time I see a new feature from like the normal C# editor get brought into Razor, it's like, oh yes, waiting for this.
We know there's still a bunch of stuff that needs to be pulled over. I worked closely with our Razor tooling team as well, and we are actively working to address getting more parity with the C# refactoring and code actions in Razor. But it is happening.
It's been a while since we had the Razor team on Community Standup too, so that's a good reminder. I should get them on.
Good work happening there's good work happening in the compiler as well. I think we talked about this at the last Community Standup, that all of the Razor tooling and Razor compiler investments are now happening in the .NET/Razor repo on GitHub. So if you have particular issues with the Razor tooling in Visual Studio that you would like to see addressed, or you have feature requests, that's the place to go. The .NET/Razor repo. It's all things Razor, .Razor and .CSHTML are being dealt with there for ASP.NET Core and Blazor.
Yeah. And I see a question in the chat about what the plans are around QuickGrid. And we are investigating possibly bringing this in as a feature in .NET 8. As of now, this is meant to be kind of a reference implementation for those who are writing components, like grid-like components. But it is something we're looking into, like actually productizing this.
I think it's worth pointing out also that, if you're looking for a grid component that really has all the bells and whistles, like all the features, QuickGrid is meant to be, a good enough grid for many scenarios. But if you really need the full feature suite, then you probably should go check out the various grid components that are available from the various component vendors, you know, Telerik and Syncfusion and DevExpress and so forth. So it's not going to have every single feature, but for most scenarios, as a quick solution, hence QuickGrid, it works just fine.
Yeah. Perfect. So with that, I will quickly walk through some of the features that this grid uses. So we have various columns for each property and one of the like JavaScript files that we're loading or audio files that we're loading. And so here we have like a property column, for example, that displays the name. And then inside of that, we have like a search button, which will display a search box and binds to the search name field, which I actually have to add. And then we use that in this filtered files property to filter out which files we're actually displaying. So that's how we can do some really basic search functionality. And this filtered files property, again, is being used right up here. Yeah, and then we have, similarly, we have a size column, and you can sort by size, which I will need a field for that as well, where we are defining how that sorting is working. And we're doing something similar for like last modified date. And then finally, which we'll get to in a minute, we will have this audio preview, which will show like a waveform and allow you to play the file and add effects to it and stuff like that. That will come in a second, but for now, let's take a look at what these changes have done. So just with this small amount of code, we can now go back to our application, to refresh. And wow, we have this really nice looking grid now. And we can sort by name. All the names are kind of similar, so maybe it's hard to tell anything's happening, but you can sort by size too, modified date, and we have the search functionality. So we can like search for a substring, and it'll only show those files that contain that substring. So very cool for almost no work, really. So yeah, let's jump forward a little bit now, and I'm going to add some like the auto preview component and then some other code as well. I just have a command here to add all that in automatically. So here now we can render this audio preview component, and I will jump into what that's doing a little bit. What this is going to do is it's going to use SVGs to render a path that renders the waveform of a audio file. And the way we do that is we are generating a string that that describes the path for the SVG. That's just kind of how SVGs work. And to do that, we have a method down here, generate waveform SVG. I'm not going to go into super big detail about how it works, but I can summarize it. It's basically looking through all of the decoded audio data. So it's looking at the amplitudes and like the waves, basically the audio waves, and based off a predefined width and like sample count, it's going to collect a bunch of those samples and compute an average and amplitude, and then determine where the point in the SVG should be for that point. So it's basically doing like a bunch of like crunching of like the audio file and generate that SVG from that. And this is going to be important later when we talk about some like SIMD optimizations that we're going to bring in near the end. But for now, this is sitting here, and yep. And so this will render the nice little waveform. And we also have some buttons for toggling playback and then applying some like voice changing effects, which we'll get into in a minute. But for now, I would actually like to modify this slightly so that we can measure how long it takes to generate the waveform, because this is going through the entire audio file to generate the waveform. So it can take, you know, a non-trivial amount of time to compute. So just for the sake of benchmarking purposes, we would like to measure that duration. So I have that here somewhere. I'll just go ahead and delete this. And we will measure the time it takes now. And it's going to display a little message next to the waveform that says how long it took. And then I'm also going to make it so that when you click on the waveform, it regenerates it so that we can run that test multiple times. So I'm going to drag this in here, and let's run that again. So let's come back to our Blazor app. Refresh.
Saw the cool little loading bar, and I think
yeah,
we're not going that into detail into that, but that's also new in .NET 7 is the ability to create loading experiences that are aware of like how much of the Blazor WebAssembly app in this case has been loaded. So that's how that little, if you saw it at the top, the little loading bar was zipping across. It was nice.
Yep.
I think Steve showed that at yeah, there it is.
Yeah.
Steve showed that at .NET Conf.
Yeah. So one thing I would like to point out here is, oh, did it stop? Oh, no, it didn't. Is as the audio previews are loading, the UI is not the most interactive. I'm actually not sure what's happening right here. Oh, there we go. Yeah, so like before all the audio previews are loaded in, I couldn't really, and it's still kind of laggy until they're all in place, but I couldn't click on any buttons. I couldn't really, like the hover effect was laggy. And it's just because, again, it's loading the waveforms for all of those audio files kind of all at once, all those hundreds of audio files. So the user interface gets a little non-responsive, as you saw just there.
There's only one thread in JavaScript.
Yes.
And you were using it to calculate lots of SVG strings.
Yeah,
exactly. So in that sense, this user interface wasn't the most intelligently designed. And one way we can improve that is actually using a built-in feature in QuickGrid. So we can come back to our code here and go back to index.razor. And there's a property in QuickGrid called virtualize. And that basically uses the virtualize component under the hood to only render the audio files that are, or the rows that are visible on the page. So we can just say virtualize equals true. And then I'll also specify an item size. And this allows the virtualization mechanism to know how tall each item is so that it knows, so I can approximate which items should be displayed in the current scroll position. So I'm going to go ahead and apply that change. And we will see that the performance is going to be significantly improved. And it doesn't get that period of unresponsiveness. So I'm going to refresh here. And now you can see as I scroll, it takes a bit for the current audio files to show up, but it's instantly responsive. We don't get that period of lag as they're all loading in. So it's a really nice improvement for, again, like barely any work on our end.
So it's just rendering the current view of the list, right? Like it calculates like, okay, these are the rows that should be shown here, and it only has to render those rows. So you're saving from having to render the whole rest of the table. Like how many audio files? Yeah, 542.
542.
Yeah, 542.
Yeah. So you're only doing like, maybe 10 or so at a time.
Exactly.
With that change.
This is such a cool thing. Like, and it's been a feature available. Like it's a common grid and Windows feature. You'll see like when they do like Explorer or something and they're going through tons of things, right? Is only render what's available on the screen. But yeah, this is awesome.
I think it's worth noting also that virtualize is a feature of QuickGrid, but it's not just a feature of QuickGrid. Like we ship a virtualized component as part of the Blazor framework that you can slap around like anything that you're trying to render. So it's not like you have to use QuickGrid in order to get virtualization functionality. We have general purpose virtualization framework components that you can use, and then QuickGrid is just leveraging that.
Yep, exactly. So yeah, this works really well and it's really responsive. But what happens if we have a larger audio file? Will this virtualization optimization really help that much? Well, let's take a look. So I'll go ahead and take a look at here. And as you can see, this one took a while to load in, and it was 211 milliseconds to compute this waveform. So you can imagine if we had an even larger audio file and maybe a large list of that, we would still get quite a bit of hiccups as we were interacting with the UI as these audio files were loading in. And furthermore, we have this little button over here that applies an audio effect, and that takes even longer to process than just generating the waveform. So for example, I have this like text-to-speech thing that says Blazor is cool. I'm not sure if that's coming out on the stream or not, but no. I can press this.
Oh, yeah. You have to show your system audio for that to work. But
yeah, so if I press this like button here, it like processes the whole file, and like pitches it down, so it's like a pitched down version of the voice, and that took 3 seconds to compute. So and for that 3-second duration, the entire UI is not responsive at all. So I'll click that again. I can't click around, like I can't scroll, I can't click this button over here until it finishes and starts playing, right? So what do we do about that? Well, one thing we can do is do AOT, like ahead of time compilation, and that will severely improve the performance of like highly intensive computations like this, and yeah, just speed up that. Another thing you can do, which is an experimental feature in .NET 7, is multi-threading. So what you could do is actually do the processing of the audio in a separate thread. So I will go ahead and show how that can be done. Let's go to.
Now we should probably put some context on using multi-threading on this. I don't want to steal your thunder.
Sure. Yeah, go ahead.
We're going to talk about this, but we showed multi-threading before. Like we had Alexa come on the show, and he showed using multi-threading in a browser on WebAssembly. So you may have seen that. That demo was done with the new just raw .NET on WebAssembly support that we added in .NET 7, where Blazor's component model isn't even in the picture. It's the new JavaScript interop model, where you can just take some .NET code and run it on WebAssembly. And we have some early preview support for using multi-threading with that model that you can try out in .NET 7. What Mackinnon's about to show here is actually doing a prototype of doing the work of getting that multi-threading support up into Blazor, so you can actually use it in a Blazor application. So this isn't available yet for you to try out in any existing preview bits. We had to do some hackery, some prototyping things to get this to work in this Blazor app. But this is something that we're working on for .NET 8, that we are planning to elevate multi-threading so that you can use it from any Blazor WebAssembly application.
Yep, exactly. So let's take a look at here. And I see some mentions in the chat of async. And this change voice async thing it's already async, but async isn't what makes it run in parallel. It makes it concurrent, but it's still all single threaded. So it's not, even if you have even if you're using async, if you have a loop, that's just that's blocking of some kind. It's going to block the whole UI thread. So what we want to do is move this change voice core method or invoke it on a separate thread rather than just on the UI thread. So what we're going to do is we're going to do await task.run and move this stuff in here. Now this alone won't make it multi-threaded because we haven't enabled multi-threading for this project. And the way you do that is by going to your project file and adding these, where are they? Here it is, CS project properties for threading. Add these properties to your CS project file, and that will enable the experimental threading support. And if we try to run this, it actually still won't work completely correctly, and I'll explain why after I show what the issue is.
And just again, those properties that Mackinnon just added, if you try to add that to a .NET 7 Blazor WebAssembly app, even if you have the WASM experimental workload installed, that's not a thing yet. That's something that we're enabling for .NET 8.
Yeah. So we will go back to this app, refresh, and you can see we have some sort of exception. What happened there? Well, the reason is, so we're getting this error, shared array buffer is not defined. And shared array buffer is another JavaScript API, browser feature that is only enabled under certain conditions. So I'm going to pull up the MDN page for a shared array buffer. And this is something that the multi-threading runtime feature utilizes in order to enable this scenario. And one of the requirements is that the web page must be cross-origin isolated. And in order for that to be the case, your server has to return these headers, cross-origin opener policy with this value, and cross-origin embedder policy with this value. So those headers have to be set in order for this API to be available. So we will go ahead and during development, one approach you can do is just make your application an ASP.NET Core hosted application and then have your server return those headers. What I'm going to do is use the .NET Serve tool to do that. So I'm going to open up that. And I've also pre-published an AOT version of this app with multi-threading enabled. So I'm going to go ahead and run this one. Here's the AOT version. This link.
Yeah, so with AOT, then the compute part of this process, all the computation you're doing to process the waveforms, that should be significantly faster just with that one change in terms of the total time of processing an individual audio file. So that will help.
Yeah, exactly.
I think it's worth also going through what those headers actually do, because it's not just that you're sending some headers and poof, everything magically works. One of the reasons those headers allow that shared array buffer functionality to be used is that shared array buffers are a pretty powerful API. And if you have code potentially coming from multiple origins, then you might be able to use that functionality to do things that could be problematic, I think, from a privacy and security perspective. And so those headers are basically locking down the browser and saying, I'm going to force this code to run in a more isolated context. So certain features that normally would work without those headers being sent might stop working. Like I think federated auth, where you're like, popping to another context is one of the known issues when using those headers. I forget the other ones, but it does create a more restricted environment for your code. If your app can't operate within those constraints, then multi-threading and using shared array buffers might not be something that's available to you. But if it is, then this feature should work fine. It's worth noting though those additional constraints.
Yeah, definitely. Yeah, thanks, Dan. Yeah. So with that, let's open up that same folder and view these files. And what we'll do is go ahead and do the same thing where we.
I see Chris Coble is now freaking out about my federated auth statement. Yeah, because I forget the exact constraint, but like the popping up the other window, like what is it, like cross-origin isolation, like makes it difficult for some of the context sharing to happen between federated auth scenarios. I believe it's a problem that's being worked on. There may be solutions, Chris, that I'm not up to date on. I just know that when people were originally talking about the COOP and the COIP headers being locking down the browser, that federated auth was one of the scenarios that people were concerned about. So yeah, at least worth checking up on is basically what I'm saying. It may be that there is a way to make it work now, like the federated auth implementers may have found some other workaround that allows them to still accomplish their scenarios, even when using those headers.
I mean, it does make sense. Like from a developer point of view, it's like, yay, multi-threading, all this stuff. But then if you think about all the different types of bugs and shared memory between threads and all this stuff and different origins and how evil the internet can be.
Yeah, and we're just it's also that we are constrained still by what the web platform, what the browsers can support.
Exactly.
We can do multi-threading, but within the constraints that the browser still imposes on us. For a long while, people wanted multi-threading. In order to even implement it, we needed support for shared array buffers, and we didn't have that across all browsers at the time. So we were sort of in this waiting pattern. We now have shared array buffers, but one of the reasons it took so long was because of these cross-origin concerns. We can get away with shared array buffers now by using these headers to put the browser in this more constrained state. It's just something you need to be aware of when you're thinking about using multi-threading in your application.
Yeah, thank you for the context. And yeah, so here I have the multi-threaded and AOT compiled version running. So what I'll go ahead and I'll click this like audio processing button again. And I think before it took around 3 seconds. Let's see how long it takes now. Wow, it took 133 milliseconds, which is a massive improvement just with AOT compilation. But in order to demonstrate the multi-threading part of it, I'm going to try to click all these at once, which might be a little hard because it does it pretty quickly. But you can see as I
go to like
as I click those around, the UI stays. Oh, it's still playing audio. Let me refresh so it's not doing that. It still stayed interactive, and I was able to keep clicking around and do things even as it was processing.
Yeah.
So yeah, that's a huge difference from what it did before, which is you click the button and then you can't even close the tab until it's done, right? So yeah, with AOT and multi-threading, it's a much smoother experience. And yeah,
so the multi-threading means that you can be processing that the waveform, like doing the pitch modification off on a separate thread. The UI thread is freed up so you can still interact with the UI. So scenarios where you want to offload work off of the UI thread, multi-threading can do that. If you want to do like multiple tasks at the same time, like is this also like because it's now processing, it could potentially like process multiple waveforms in parallel, so you potentially get some performance improvement through that as well by just leveraging more cores, I guess, on your machine instead of just doing everything on one core.
Yeah, exactly. And you could apply the same optimization to the waveform processing by doing the same optimization. So you can do like wait test.run around this too, and then even the generation of the waveform will be made faster. So
oh wow.
So yeah,
okay.
Yeah, you could absolutely do that too.
And I know last time Alexei was on this call and he was sharing with us the early work on multi-threading. I think he talked about how we're in the browser, and the way we're getting threads is by, I think, spinning up service workers for each of the threads. And the implementation at that time was that there was a pool of I think it was 4 threads that you could really utilize, simply because of the limitations the browser imposes on how many service workers you can actually create. Is that still the case here? Do we still have that constraint? I assume so.
I believe that is the case. Yes.
Okay. So you can have as many threads as you want, as long as it's no more than 4 at any given time. Is what you get with the browser multi-threading. Yeah, it'd be interesting to hear from folks. If that constraint is problematic. Like I'm sure for some scenarios where you're just trying to like push one thing off to a different thread and free up the UI thread, that's probably fine. Like you just need one to do that. If you're trying to like spin up 100 threads to like parallelize a lot of work, then that's not something that the browser just inherently supports yet, unless you only need 4. Like 4 is about what we can do currently. Maybe the browsers will evolve and that will change, but that's the constraints we're currently operating under.
Yeah. I don't quite remember if that limit of 4 was something that. Sorry, go ahead.
Which do all browsers support this, the shared array buffers and everything? I missed it.
Yep. The holdout was Apple, right? The holdout was Safari, and then they got their shared array buffer support in. So all the modern browsers should have this functionality now.
Fancy.
We're going to talk about SIMD here in a minute, and SIMD we still have a limitation on Safari, I believe. Like we're still waiting for that to come in. I heard just this morning from our the .NET runtime folks who follow a lot of the progress at the WebAssembly level that core JavaScript has now picked up some of the SIMD APIs, which should flow into Safari. So I guess there's some signal that soon SIMD will be available for WebAssembly SIMD in Safari as well. So that fingers crossed that is coming soon.
Yeah, perfect. So I guess on the topic of SIMD, let's jump ahead and see SIMD support now. So what I'm going to do is replace this generate waveform SVG implementation with one that just has a few lines changed to support SIMD. And I'll just fix the indentation here because that's bothering me. And what this is going to do is it's using this like system.numerics or runtime intrinsics API vector 128. And what this is going to do is it's going to allow us to process 4 data points at a time in the audio file. So rather than, for example, computing a minimum of 1 data point at a time, we can compute a minimum of like 4 data points at a time in a single instruction. So it's like single instruction, multiple data is what SIMD stands for. So the code has not changed that much other than using vector 128 and then combining the results of all the mins that we computed in this loop into a single min and then using that instead of what we were doing before. But yeah, the details aren't super important, but the point is that you can use these APIs now in WebAssembly if you have SIMD enabled. And in order to do that, you go to your CS project file again, and there's another property you can use, WASM enable SIMD, and we just have to do that. And that should be all you need to do in order to enable that scenario. And I'm not going to build this right now just because it takes a while to build, but I have it pre-built, kind of like I did for the other one. And we can see that example too. And I got kind of mixed results when testing this to see like the specific performance improvements. We might see like a millisecond faster in some scenarios, just a heads up, but I will go ahead. And
running through StreamYard also can sometimes impact the performance of these performance demos are always a little dicey, particularly if you're running off a laptop on StreamYard, but we'll see.
Yeah, so here I'm doing the non-SIMD versions, taking, I don't know. Oh, actually, sorry, I shouldn't be using that. It's the effect generation that is using SIMD. So let's actually test that. I'll go ahead and click this, see how long it takes. All right, so 625 milliseconds about. And let's try over here. Please be faster. Okay, about the same. But it's
the timing that you're showing, are those showing the, okay, I can't see it. Is the time showing the effect generation time, or is it showing the, yes. Oh no, it does say effect. Okay, so that's the effect.
It is. Well, anyways, So, yeah, so it's within the margin of error. It could be we have StreamYard running and other factors as well, but yeah, so that's SIMD support, and I don't think there's too much else to say about that I have for this demo. But
I know like one area that we're dealing with SIMD, like because SIMD pulls in a lot of types that are heavily generic, like those vector types, lots of generics involved there. One of the tricky technical bits that we have to deal with is, well, when you're doing ahead of time compilation with generics, one of the core problems you have to deal with ahead of time compilation is the problem of generics explosion, like trying to figure out like, okay, what are all the generic types that I actually need to ahead of time compile to actually make the runtime work. The more generic types you use, the more tricky that becomes. And with SIMD, there's a lot of them. So getting the generated app, the published app size to be reasonable when you're using a lot of the SIMD types is an area that the .NET runtime team, the folks that work on ahead of time compilation are actively investigating and working on, just to give you a feel for like some of the things that our team has to deal with in order to bring these features to actual production level quality. You can play around with SIMD today with .NET 7. I believe it's in the WASM experimental workload, as is the early WebAssembly multi-threading bits are there when you're using the new JavaScript interop API, so that you can try that out. But if you're ever wondering, like, well, what was there? Why didn't you just ship it in .NET 8? It was done. Like, look. Well, for getting it up into Blazor is additional work, and also these optimizations that we do to make sure that the app size still stays reasonable when you're using all these generic types. That's part of the work that we do to make the feature ready for use.
Mm-hmm. Some of these processing things too, like there's a like a cutover point, right, where you bring in a lot of you know what I mean? It's your app may be larger, it's got more complexity, but when you're processing over, maybe like if you're processing a gigabyte size file or what, you know what I mean? There's a file size or a processing amount where it's going to be worthwhile.
Yeah, it's an interesting matrix of constraints that the .NET runtime team now operates under. Like we have runtime performance goals, like we want the code to run fast, but at the same time, we want the code when you're doing ahead of time compilation scenarios to be small, like particularly for like WebAssembly use cases or some of the native AOT scenarios that are coming down the pipe for .NET. You want those apps to be small in size. Often doing runtime performance improvements. One easy way to do that is by just increasing the amount of size on disk of like pre-generated code and data sets and such. But if you care about size, you can't be doing that as much. So it's a tricky problem that we try to tackle in order to get good characteristics on all dimensions, on runtime performance, size, memory usage, all these things. Yeah, that's cool. Okay, so that's the new stuff, right? So multi-threading and SIMD in a Blazor WebAssembly app that's working on at least Mackinnon's box and Steve's box. Those are features, though, that we plan to deliver, though, in .NET 8, mm-hmm. Right? These are things that we actually expect to show up in the upcoming .NET 8 previews. I think the first .NET preview will probably be February-ish. I wouldn't expect much new. I don't if you've been around for a little while with .NET, we're on this yearly cadence. Like the final release for .NET 8 will be November 2023. There'll probably be a .NET Conf event that you can get excited about. It will be the next long-term support release, so that's super cool. It'll have a full 3-year support lifecycle. The previews typically start around February, and the first preview is usually just like, can we get a build out the door? Like, can we change all the TFM, the target frameworks to .NET 8 and build an SDK and actually get it out and have the stuff that used to work still works? And then features will start lighting up in future .NET previews. And expect about a .NET 8 preview every month or so is what we'll churn out. And that's your opportunity to try these features out and let us know how they're working for you and if they're ready to ship in the actual LTS release later in November.
Cool.
Do we have any questions that we should tackle? I know there was some questions about will the multi-thread. I saw one from Chris about will multi-threading kick in for the async await patterns. Like if you're using async await and it actually needs to kick off a thread, will that work?
Yeah. So the semantics around async await won't change. Like you won't have rendering code run in multiple threads automatically. But if you do something like use the thread APIs directly, or do something like task.run like we're doing here, then it will kick off a new thread. Yeah.
Cool. All right. Yeah, I started a bunch of other. Let me see. Okay. All right. I'll just go through them in semi-random order, I guess. I thought this one was interesting. How do you update a Blazor server app without downtime for users?
Yeah, that's a great question. That's tricky. So the problem here, right, is that Blazor server is a connected stateful model, right? Like someone's connected to your server, they're using your application, they've got memory, like the state that's associated with that user we call a circuit. So you have a live circuit on that server that's handling all the UI interactions for that user. Now you want to push an update to your application. Normally, if you just like push an update to that app, often you'll like recycle the server, the circuit state goes away, and then you've just killed that user's circuit. Their current session is not really the right word, but their I'll use it anyway. Like their app session with that particular server. So they have to reconnect, and then any state that they had, if it wasn't persisted by the application anyway, Blazor server doesn't try to persist the state from a circuit for you. So it's up to the application to decide if there's any circuit state that you wanted to have persisted beforehand, and then you rehydrate. So if you really want to be careful to make sure that you're not killing anybody, kicking anybody out of their current session, you'd have to wait till everything's like drained, like all the live circuits are done before you start switching people, moving traffic over to a new server that has the new bits. So that's the kind of thing that you'd have to deal with. In .NET 8, we're trying to do some work to make it easier to do things like persist state, pause circuits, rehydrate them, to handle these scale out and roll out scenarios. So those are a number of features in .NET 8 that we're looking at. Honestly, it's a set of features that we've been looking at for a couple releases now, but the .NET 8 is when we expect to have it happen. You've probably heard me talk about pause and resume and monitoring the state of circuits, APIs for doing that, being able to eject circuits from the server if you want to do that. That's a set of work that we are, I feel very confident that we will tackle in the .NET 8 timeframe. We've pushed it out long enough. It didn't happen in .NET 7 because Maui happened. Like Maui took up like half of the .NET 7 release. We wanted to get the Blazor hybrid work out the door, and that just didn't leave a lot of time to get a lot of the stuff done that we had hoped to. Maui took a little longer, honestly, than we had expected. But for .NET 8, we think we can definitely do it.
That's one of those areas where it's more complicated server side than client side, right? If it's Blazor WASM, then rolling an update's probably a little easier to reason about.
Yep. Blazor WASM is a pure client side model. So you just push new files to the server, and then once people download the new files, they've got the new app, and they're good to go. Yeah. So it is. But Blazor server is as named a very much a server model, and you're managing the user state with your servers.
Cool. All right. Question about identity or authentication authorization with Blazor.
Just reading the rest. If you use identity but don't use EF, it would be a bonus. Trying to use existing roles and tables. So for authentication authorization, we have project templates that you can just use. Like you can do file new project and create a Blazor server or a Blazor WebAssembly application, and there's like a little select which auth type you want, and you can use ASP.NET Core Identity as your user store, like for your usernames and passwords and profile data and all that such. You can use that functionality, or you can leverage like a hosted identity option like Azure AD, Azure Active Directory, for handling your identity concerns. So those are built into the templates. You can take a look at how those are set up and extrapolate them to your scenarios. For like using they are using eIdentity Framework Core, particularly in the ASP.NET Core Identity case. By default, we use EF Core for the data storage. ASP.NET Core Identity is designed to allow you for the persistence layer to be swapped out with something else. Like if you don't want to even use EF Core, you can put in something else. It is I wouldn't say it's going to be a simple task, but it is a designed part of that framework. So there's a way to do it. I don't know of any good samples off the top of my head of using ASP.NET Core Identity with non-EF Core backing store. There may be something out there from the community. I would check the doc set for that part of the extensibility model and see what's available. But yeah, that's going to be a more advanced scenario. I'd be interested to know, like, well, why not EF-Core? EF-Core is great. Use EF-Core. But if you really can't use it, it should be possible, but it might not be super easy. For authorization, like at the authorization layer, Blazor will have a notion of the authentication state, like who the user is, that we will set up for you when you use one of those templates. Either that authentication state is coming from like a auth cookie in the case of Blazor server, or if you're dealing with Blazor WebAssembly, typically you're dealing with that using like an OpenID Connect based flow, and you're getting an ID token that's setting up the authentication state. And then once the authentication state is established, you can use all the authorization features. Like you can slap authorize on a page. We have the like authorized component that says like only render this part of the UI if the user is authenticated or matches this authorization policy. There's a bunch of authorization features that you can then leverage, and those are all, again, you can check out the Blazor docs on how to set those up.
Cool. All right, let me see.
I probably should also say that we do know that authentication in general is kind of hard, kind of complicated. There's been a lot of Reddit and Twitter threads with people saying, why is auth so hard? For .NET 8, there is actually a fairly significant effort to look at how can we simplify that? Like how can we make the most common scenarios easier and more approachable? Nothing to show there yet, but there's been like I think John, you mentioned David Fowler's like to-do application projects. A lot of those to-dos is him also setting up authentication using different approaches and comparing them to see like, okay, how does this feel? Would this be easier? Would that be easier? Different protocols, different APIs in an effort to make auth easier in .NET 8.
Cool. Yeah. All right. Yeah, that's a common thing. Like we have this yearly cycle, right? So everyone's super busy, especially as it gets towards November, getting the thing out the door. And then very commonly during December, people are like, let's hack on it and let's, try some things out. So it's just fun to see. Let me see. For virtualization, the question here was about rendering items above and below so that you're not waiting for scroll to actually.
This is totally a Mackinnon question. This is right up your alley, Mackinnon.
Yeah, I believe we have a property like overscan count or something that lets you configure that. Something like
that.
We
do that already, right? Like, isn't that in some sense, is that by default? Will it do that, or do you have to?
I think there is some. I don't remember specifically what the default value for that is, but it does make sure that like if you're not scrolling, there's no blank space like at the top or the bottom. But if you scroll quickly, like depending on how fast you're scrolling, you might still experience that. And I believe there is a property, I think it's overscan count, that allows you to configure that.
Yeah. But if you like grab the scroll bar and you're like in a list of 1,000 items and you jump all the way down to item like 800, most likely those won't have been overscanned. So you will see a little delay while at least the initial render of those kicks off. Mm-hmm. But you can, I think, control the placeholder that gets displayed, right? Like you can put like a little, if you want to show something while you're getting the actual data, you can do that too.
Yep. Yeah, you can define a placeholder template. So it's, just not like a blank area when you're scrolling. You can put something that says loading or have some sort of like, fake data there or something. Yep.
This is a time where I will state one of my pet peeves, which is if you're having something that says loading, don't make it a lie. Like for instance, if it's a bank account, don't show $0 or something, right? I've seen this. I see this regularly in like
John, are you sure your bank account just doesn't have $0?
No, it's negative. Man. It's negative. And Okay, so moving on. JS interop, does that have, what's the overhead there?
So often there's a serialization overhead, like you're going through a serialization boundary, like we're creating a JSON payload for the data that needs to go across the JavaScript interop boundary. So there is a little bit of overhead. Actually, that's one of the, particularly with the Blazor's generic JavaScript interop model, like we have a JavaScript interop model for Blazor that's intended to work across all ways that you might host your components, whether you're doing Blazor WebAssembly, Blazor Server, Blazor Hybrid. We have a single JavaScript interop model that you can code against that will work with all of those. And that's the one actually we encourage you to use. It does have overhead. You can optimize some of the overhead that model imposes if you know, for example, that, I know I'm running on WebAssembly. I know I'm right there in the browser already, and you can do tricks with like sharing memory pointers and such. And that's in part why the new JavaScript interop model was introduced, because it's a fully featured, optimized way of doing JavaScript interop when you know you're running on WebAssembly. It still does some amount of marshaling. like it is a marshaled model. So the like marshaling, like it needs to marshal data across the boundary, but it's very efficient at it, and so it should be really good. So if you're performance sensitive on the JavaScript interop bit, and you know you're going to be running on WebAssembly, you can use that new JavaScript interop model to get some better performance. If you're not sensitive to performance, then we strongly encourage you to use the generic Blazor JavaScript interop model, because that will allow your code to work in all of the Blazor places.
Cool. All right, I had a disconcerting question come in, which is, why is my plant blinking? And honestly, I don't know. Do you guys see this?
Yeah.
My plant is blinking now. It's not a green screen. It's a real plant. I don't know. I'm really concerned. So we'll keep an eye on that plant.
Your plant is fluttering in and out of existence, John.
It's in a quantum state.
Dimensions. Yeah.
All right. This question came up several times. I know you already answered it probably 3 times, but just to be sure, timeline, November, every November comes out, .NET 8 LTS coming out in November, and then previews starting, I think you said February-ish.
Yep. And then for a roadmap, we last month went through all the things that we're thinking about. And we invited the community to participate in those discussions, like comment, upvote, GitHub issues. If there were items on the list that we presented that you felt were missing, let us know. If there are things that we are planning to work on that you think are not worth the time, then let us know that too. So that list is reflected on GitHub. You can look at like the .NET 8 planning milestone and the various .NET 8 related milestones to see what's sitting in there. If an item is currently sitting on our backlog milestone, that means we're not currently considering it for .NET 8. So that's one signal you can use. We will, every year, we generally create a GitHub issue that is our ASP.NET Core and Blazor roadmap issue that lists all of the items that we're expecting to tackle for the release. I expect we'll have that put in place probably within the next month or so, hopefully before the first .NET 8 preview. There are some like broad .NET 8, thematic discussions internally that are still in progress that we're kind of waiting to settle before we go public with a roadmap. But you should expect to see something published soon. As always, with a roadmap, it's not a contract. Like things always change. It's hard to predict the future a year in advance. We always end up having some items on our roadmaps that end up falling off. Last year in .NET 7, I think we were particularly bad, and I think a lot of items end up not making it for .NET 7. Again, that was because of the MAUI efforts and so forth. For .NET 8, we're probably going to try and be a little bit more conservative about what we put on that list, so that you can feel more confident that the things we're saying we're going to tackle actually do get delivered. So look for that roadmap to be published. We'll definitely share it here, and it'll be a GitHub issue, so you can comment on it if you if you are super excited about it, or if you don't like some of the things that are on the roadmap, you can let us know once we get that published.
Cool. How do you think about if something doesn't make .NET 7? Is it then, do you kind of put it back on the board for .NET 8? Is it kind of automatic?
We reevaluate it for .NET 8, and usually that means it's a good candidate for .NET 8. There sometimes are things that come up that end up being like new priorities that we weren't considering in the previous release that might mean it still gets shuffled below some other items. But for the most part, if it was high for the previous release, it probably is high for the next release too. In the past, I've looked at, I know there's kind of the big Uber issue that kind of tracks all the stuff. But then is themes of .NET still? I loved themes of .NET. I thought that was a great idea when we did that in .NET 6. If you don't know about themes of .NET, it was a website that we put up that was kind of a view over GitHub that kind of grouped the main work items for a .NET release under these high-level themes, and you could drill down and see what's in those themes. What are they made of? It kind of gave a picture of these are the big ticket items that we're working on for .NET 8. For .NET 6 was when we did it at the time. We didn't really use it for .NET 7. .NET 7 was much more sort of bottom-up style planning than sort of these top-level broad themes that got defined. I think that was one reason that happened. And I haven't seen any movement yet for it to be used in .NET 8. So yeah, I can't commit. I wouldn't expect to look at themes.net as a view of what we're doing in the release. What I would expect is that there should be like a sort of a framing blog post, which is usually what we do near the beginning of the year, to say .NET 8, Preview 1, high level, here are the things that we're working on across the .NET platform. I mean, here we're just talking about Blazor and ASP.NET Core, but the .NET platform is huge, right? Like, you got runtime, you got the core libraries, you got, WinForms, WPF, you got Maui, like all these things will get sort of summarized in a broad framing blog post sometime in this first quarter, presumably before the first preview release. It might be the first preview release blog post kind of includes a lot of that framing content. And that'll give you an idea of like what we think are the high level areas of investment in the .NET platform for the next release.
Cool. All right. Just a few more questions here. So for multi-threading, is UI thread always single threaded?
Yes.
Yeah.
There's one UI thread. Yeah. Multi-threading gives you a way to move work off of the UI thread so you don't block it. And that's what Mackinnon was showing.
Cool. All right. Question about WASI.
It's being worked on. Like it is an area of investment for .NET 8. Like I don't, just as with all the .NET 8 roadmap stuff, we're not ready yet to say how much will get done. But we're definitely working on WASI related functionality in the .NET 8 timeframe. Does that mean that there will be like production ready WASI SDK for .NET in that timeframe? We don't know that yet, but it is actively being worked on.
Speaking of which, I follow that repo, and I've seen Brendan Burns has been contributing things and filing issues and stuff. He built some WASI containers for a bunch of different things. Brendan, like one of the inventors of Kubernetes, I believe, and smart person. So fun to see him hacking on that stuff.
Yeah, cool. Which repo are you talking about? Which repo is that? That's the
dev WASM. Let me see. I guess this is his repo. So he's been filing issues on the WASI Blazor one. I'll throw it in the random. This is a dev container WASM.NET development thing that Brendan was spinning up.
All right, cool. Yeah, for the actual .NET runtime work related to WASI, I think all that work is happening in just the .NET runtime repo. So you can, if you really want to stay up to date on the latest commits and things that are happening in WASI, you can probably just watch the .NET runtime repo and see what's going in. Yeah, that's where I think all that work is occurring.
Cool. All right, some questions on, is my code, my WASM code, can people decompile it? Is it clonable? All that sort of stuff.
Oh yes. Can people see my code? Yes, they can see your code and they can decompile it. Yeah, when you build a Blazor WebAssembly app, you're downloading a .NET runtime, some core framework libraries, and your app code to the browser. And at that point, it's public. Like, it's public code to whoever wants to grab it. And if they want to decompile your assemblies and see what you wrote, they can absolutely do that. Just like with JavaScript, right? It's the same deal. You can go into the browser dev tools and look at the JavaScript that was downloaded for any website that you're visiting. It's the same idea when you're doing Blazor WebAssembly for the client side logic. If you then build like some minimal APIs or some web APIs, all that code obviously is running on the server. So if you have functionality that you don't want to go down to the client, maybe the dependencies are just really large and you don't want to bloat the app size. Maybe you have some proprietary logic in there that you just don't want to share with the world, then keep it on the server, put it behind an API, and then you just call it from the client using some secure mechanism. Alternatively, you can just build a Blazor server app, and then you get interactivity like a spa, but all of the code stays server side. None of your .NET code will go down to the client. So yeah, a Blazor WebAssembly app, you can think of it is that it really is just a JavaScript app that happens to be running some .NET code. It's just a bunch of static files that are being downloaded and run client-side in a browser.
Cool. All right. I'll keep it to, I think, one more question here. This one's neat because I think I know the answer to this, and it's kind of... So WebSocket in Blazor for streaming. So I saw there was it WebRTC? Something like that. I saw a demo of this in .NET 7.
So, okay, if you're building a Blazor WebAssembly app, then you're running client side in the browser, and if you want to set up streaming, or if you want to set up a real-time connection with the server, then you can just use the normal .NET SignalR client library and set up a connection to your SignalR hub on the server. That will happen over WebSockets under the covers. Under the covers, it's going to call into the browser's WebSocket APIs for setting up that connection, which is fine. And there, you got a real-time connection. You can push things down to the browser. You can send things up. For streaming in particular, you could also, if you wanted to, use gRPC. Like you can use a .NET gRPC client from a Blazor WebAssembly app and talk to a gRPC service. And specifically with Blazor WebAssembly, because you're dealing with a browser client, it actually will be gRPC Web. It won't be like the full gRPC just because of browser limitations around the HTTP protocol. But you can use a gRPC Web client to deal with the server, and I believe gRPC has streaming features. So those are, you just use normal .NET APIs to talk to your server and however you'd like. You could do HTTP client for HTTP calls, SignalR for real-time communication, gRPC Web for gRPC style calls. All those things are possible.
Okay. Just since it kind of seems to relate for me, there's a question here about, can you like mix and match Blazor server and Blazor WASM?
Mackinnon, can you mix and match Blazor server and Blazor WebAssembly?
We do have some prototyping work that is exploring possibly combining those two models in a meaningful way. I would say we'll get into the details about what that might look like at a future community stand-up, but that is something that we are investigating.
Yeah, we almost did want to show an early prototype demo of something along these lines. This is something we've been talking about for a while, like the ability to have multiple Blazor apps in the same page. Like today, if you load blazor.webassembly.js or blazorserver.js, they kind of both populate the global namespace. So they don't sit side by side with each other very well. That's problematic for like micro front end scenarios and those types of things. This is a part of a much broader area of investigation for .NET 8 about how can we better align the Blazor server and Blazor WebAssembly programming models. Nothing to show or share about that yet, but like Mackinnon says, stay tuned. Maybe next month we'll have some cool stuff to show about that.
Awesome. All right. Well, I think that's a good place to wrap up. So thank you for the amazing demos, Mackinnon. This is really cool stuff, and it was fun seeing how like building on top of the demo that Steve showed, and I shared the links out for that, and then turning on new features to optimize it further and stuff. So very, very cool. All right. One other thing is, I guess we'll be sharing out at a future stand-up, like survey of some sort. I think I was maybe said I was going to do it and didn't, but to get your ideas, what would you like to see in future stand-up? So like you can leave comments on that. There's no promise you will get anything that you want, but it's just would be helpful for us to know what you find interesting. So your chat, we go through the chat messages afterwards, and then also the comments, we do keep an eye on those. So let us know what sort of things you'd like to see on this and any of the stand-ups. All right, well, let's wrap up there. Thanks a lot, folks.
Thank you.
Thanks.
Bye everyone.